Here's a few transformation of functions problems. So let's just say I have the graph here of a function f of x, okay? And I'm going to tackle three parts of three different problems that ask me to find the domain in part A, find the range in part B, and then sketch the graph in part C. So first off, we probably ought to talk about what the domain of this function is. That's the list of possible inputs. You could think of it as the shadow. The domain would be -2 up to 2, but we're not including 2, right? Because 2 isn't a valid point input. The range is the list of possible outputs. That's the sort of vertical shadow. It's from 0 to 2, right? You could get an output as low as 0, an output all the way up to 2. No issues that you could get multiple outputs of, say, a half. It's just in the range once. Okay, so let's look at this first problem. Let's imagine that g of x is defined by -1 plus 3 f of x. Now, don't let the order fool you. You might be more used to seeing this as 3 f of x minus 1. This is a shift vertically down by 1. This is a stretch, a vertical stretch by 3. Now you might ask, which of those should I do first? And the answer is we are concerned here in part A with the outputs, right? And all of these have to do with the outputs. They are on the outside, and so they have to do with the outputs. I should say the domain is concerned with the inputs. Which x's can you put into f? Exactly the same ones as g. Right? And so the domain's actually not going to change at all. The domain is going to be -2 to 2, like that, because if you plug in, say, -2 here, it'll just be the same thing as plugging in -2 here. All is fine. Which one I'm concerned about that's going to change, because this changes the output, okay? So think about it. Here I have an output of 0 to 2. What happens if my output goes from 0 to 2? So essentially, I'm asking, what happens if you get a 0 here as your output? Well, it's 3 times 0, sort of order of operations tells you you're going to do the times 3 first, the stretch first, then the subtracting 1. And on the right end, also 3 times 2, since that's the largest possible output, minus 1. Oops. Yeah. Getting confused doing the range, right? Okay, so what happens here? 3 times 0 is 0, minus 1 is minus 1. 6 minus 1 is 5. That's really what I have. You could think about the same thing here. It might be useful on C to think a little bit about a table, okay? For the function f, you're sort of dealing with the points, let's see, -2, get out 2, 0, get out 0. And, you know, sort of, maybe I should put an asterisk here because you can't quite plug in 2, but if you're getting really close to that point, you kind of want to think about what's happening. What's really happening to the function g? Well, you can still plug in the same inputs, right? -2, but what's going to happen when you get out 2? Well, you get out 2, it's times 3, and then you're subtracting 1. So that means at -2, you're going to get out a 5, right? At 0, this isn't fiddling with the inputs at all, but at 0, normally f would output a 0. So this is 3 times 0 minus 1. And then if you were plugging in 2, notice this point still isn't quite in the domain, but it gives you an idea of what's happening in the domain. If you put in 2, think about that. What do we get out? The output's 1, so 3 times 1 minus 1 is 2. Okay. Yeah, okay. Just had to double check that I was actually doing that math right. Okay, so my domain's going to be the same. So I might do a graph. I might put the same domain, sort of -2 up to 2. But my range is going to be -1, so I might put a hash mark for -1. 1, 2, 3, 4, 5. Imagine those are perfectly evenly spaced. I'm going to start out here, right? I'm going to go down to -1, straight, right? And then I'm going to curve up, to 2. That's going to be my open circle. Going to look something like that. So in hindsight, you can think about these in sort of the classic geometric way. What did we do? We stretched this graph vertically by 3. So that goes 3 times as high, would go up to 6. This goes 3 times as high, that would go up to 3. And then we shifted the whole thing down by 2. Hopefully that makes sense. Okay, so same thing, but now we're going to deal with the inside. Now the inside, right, that has to do with inputs. Okay, and so the game here is going to change the domain, but just a spoiler alert, it's not going to change the range at all. The outputs will be exactly the same. So going back to the original function, 0, 2, boop. But what are we going to do to the domain? Well, essentially, the domain used to be that the inputs had to be between -2 and 2, right? Now, the inputs 2x minus 1 have to be between this and that. Those are the inputs that have to be between that. Think about how you would get things out of the middle here. You'd have to add 1 to all 3 terms. So that's now -1. This is now 3. Now you'd have to divide by 2. This is the reason that things on the inside often work the opposite of how you'd expect. Subtracting moves right. Multiplying by 2 is actually a horizontal compression, right? Divide by 2 here, so -1/2 is less than or equal to x is less than or equal to 3/2. That's the domain. -1/2, I shouldn't say less than or equal to, these are less thans, up to 3/2. Okay, so you could do a little table on part C, or you could just sort of skip straight to the graph. Okay, now the heights are going to be exactly the same. The heights are going to be just the same as the original picture, right? We're going to get up to 2, right? But as far left as you're going to go is -1/2, and as far right as you're going to go is 3/2, right? So what does that picture look like? Well, if you think about this in sort of the reverse order, because we're working backwards, you're thinking about essentially shifting the picture right 1. Okay, so imagine shifting that picture right 1. That means you'd be going from 1 to 3, and then horizontally compressing it by 2. So this dot up here is now there. The dot at the other end is now there. The midpoint is now there. And so you can sort of see what happens there is that shape has been, and the order is really important here, it has been shifted right 1, then compressed, because you're sort of working from the outside in here. That's what the graph looks like. Let's put them both together. Okay, so this is the same vertical outside work as number 1. Okay, so what's that mean? That means that your range is going to be the exact same calculation as we did here. -1 up to 5. The domain looks exactly the same as here. It's tweaked the same way. So that's -1/2 to 3/2. You'd use the same logic you did right here. What about part C? Well, we're going to have to put all of these things together. So you know from the domain and the range that essentially what we've got to do now is we've got to make something that, oops, lines are getting a little messy, goes from -1/2 up to 3/2, right? Goes down to -1, 1, 2, 3, 4, 5, goes up to 5, right? So it's sort of a compilation of the horizontal picture that's happened here and the vertical picture that happened here. So we're on the inside, we're working we're essentially working outside in. So this looks like, hey, we moved the picture right 1 and then stretched by 1/2. What's that do? It takes this dot, 2, -2, moving it right 1 and stretching it by 1/2 puts it in an x value of 1/2. But the output then, that was +2, gets multiplied by 3, 2 times 3, and then subtracted 1. So that's going to be the point, right? So essentially your table point here, if we were doing both of these things, the x value would be -1/2, the y value would be 5, okay? That's what's happening there. Think about that next point, 0, 0, moving it right 1, and then stretching by 1/2 or compressing by 1/2 means we're at 1/2. What about the height? The height was 0, multiplying by 0 does nothing, subtracting 1. That means we're at this point right here. What about sort of that next magic point, the one that I'm going to put the asterisk by? That would be the point originally 2, 1. We'll move that 2 right 1, that's at 3, divide by 1/2, that's at 3/2. Notice the domain doesn't quite go up to there, but the point's really relevant anyway. The output was originally 1, right? And so what are we going to do here? I'm going to multiply that by 3. That makes it 3. -1 is 2. That means this open dot is there. Go down. And you could do this for any intermediate point also, but this gives you an idea of sort of the points that hold everything together. Hope that helps.